Good morning, everyone. This morning we are covering chapter 5, looping on C++. This is basically what's called a repetition. There are three kinds we will discuss. We have the while loop, we have the do while, and then we have the for loop. We'll discuss Sentinels, deciding which loop to use, nested loops, breaking out the loop, using files for data storage, creating good test data. So a loop is part of a program that may execute more than once. While loop, and the format here is while loop, and in the format there is no semicolon there, the condition, and then the braces, then you have the statements. So the braces can be omitted if there is only one statement in the body of the loop. So condition is evaluated. If it's true, the statements are executed, and then the condition is evaluated again. If it's false, then the loop is exited. An iteration is an execution of the loop body. So here you have the condition for the while loop. So this is the flow chart. If it's false, it will exit, and if it's true, it will execute the statements. So the way to write it is here you have a while loop, you initialize it, you have int value equals 5, and then while value is greater than or equal to 0, then C out value, and then you have a space, value equals value minus 1, and then produces 5, 4, 3, 2, 1. That's the space that was added at the end. So a while loop is basically a pretest loop. So the conditions are evaluated before the loop executes. You can see the example on page 246. If the condition is initially false, then the statement in the body of the loop are never executed. If the condition is initially true, then the statements in the body will continue to be executed until the condition becomes false. Exiting the loop must contain code to allow condition to eventually become false, so the loop can be exited. Otherwise, you have an infinite loop or a loop that doesn't stop. In the past, you have to stop the whole computer, but right now you can just exit out of that screen that you're in. Example of infinite loop is if x is equal to 5, then while x is greater than 0, then C out x. Now x will always be equal to 5, right? X is the condition will be true. X is greater than 0. Okay, so it will keep on going. You have some common loop errors, so don't put in a semicolon immediately after the condition. Don't forget to have the braces. This is not Python. And then don't use the equal to when you mean, don't use the assignment when you mean the equal to of two of them. The programming style loop body statements should be indented. You can align the braces with the loop header and place them on lines by themselves. So the convention above makes the program more understandable by someone who is reading it. They have no effect on how the program compiles or executes. It also helps when you're troubleshooting if there are any issues and you have braces not matching. You can actually match them if you line them up. You can use while loop for input validation. So loops are an appropriate structure for validating user input data. Prompt for and read in the data. Use a while loop to test it. If the data is valid, enter the loop only if the data is not valid. Inside the loop, display error messages and prompt the user to re-enter the data. So the loop will not be executed until the user enters valid data. So here's an example of input validation loop example. So here you have to enter a number between 1 and 100. I'll guess it. So you read the number, and then you do the while loop. You can maybe run this as a test. Increment increases a value in a variable. ++ adds 1 to a variable. So val ++ is the same meaning as val equals value +1. Decrement reduces the value in variable. So minus subtracts 1 from the variable. So it's the same as saying value -1. You can use it in prefix mode before or a postfix mode after a variable. In a prefix mode, increment or decrement the variable, then return the new value of the variable. So it's this return new value of the variable that is used in any other operation within the same statement. So some examples of prefix mode. And the postfix mode returns the old value of the variable, then increments or decrements the variable. So it's this return old value of the variable that is used in other operations within the statement. Some examples of that you can run. So increment and decrementing can be used in arithmetic expressions. So you have results equals num1 plus plus, or minus minus num2, must be applied to something that has a location in memory, cannot have a result like this. It can be used in relational expression if plus plus num is greater than limit. Pre and post operations will cause a different comparison. You can look at some of the examples mentioned in the book. You have counters, variable that is increment or decrement each time a loop repeats, can be used to control execution of the loop. So it must be initialized before entering a loop, may be incremented or decremented either, inside the loop or in the loop test. You can have the user control the loop, so a program can be written so that a user input determines loop repetition. Maybe we'll run an example of that. Can be used when a program processes a list of items and a user knows the number of items. User is prompted before a loop, the input is used to control number of repetitions. Okay, so this is user controls of the loop example. You have int num limit, and then you have table of squares. Again, when you see these type of examples, try to run them. Then we have what's called a do while. So it's a post loop. Just to give you an idea how these loops work, the one we have just seen was the while loop, right? So it checks first what? The condition. And if the condition is true, then it executes the statements that are in there. If the condition is false, it exits, right? So as long as the condition is, it would execute. So for example, let's think of it in terms of, let's say like a drive-through. If you go through a drive-through, right, and you're trying to order food, what is the first thing that they check? The first thing they check is that you actually paid the money, right? And then after you have paid the money, then they will give you your food. Now, if the first window asks you or checks if you have paid for it, and the answer is false, they won't give you the food. So this is, it checks the condition first, the precondition. Does that make sense? Mm-hmm. If it's false, get out, you don't get your food. The do while is different. It's not like a drive-through. It's like a dining restaurant. So do while is a post-test loop condition. It's evaluated after the loop executes. So this is the format. You have the format do something, then after that check the while loop. So what do like a dining restaurants do?
After you eat anything.
No, what's the first thing you do? No, before you do it, when you go to a dining restaurant. They sit you down and then? They give you what?
Menu.
No, before they give you the menu.
Water.
They bring you some water and you have some bread on the table, or maybe you have some cheese, salad. Right? And then after that, they'll be like, we'll come back, here's the menu, right? Yeah. Somebody could actually eat that food and then say, excuse me, I forgot my wallet. Are they going to hold you? No, they're like, okay, fine, come back again. You can get on your bike and go. Right? So the condition is checked later. First, it has to do something. Does that make sense? So the do while is like that. You have the statement, then the condition. If it's false, out. If it's true, then you go back in. Okay? But at a drive-thru, at fast food restaurant, they make sure that you get the money before they give you any food. Does that make sense? So the loop always executes at least once for do while. At least they give you something first. Some bread, some cheese, some water. Okay? So execution continues as long as the condition is true, so the loop is exited when the condition becomes false. So the braces are required even if the body contains a single statement. And then the semicolon after condition is also required. So you can have a do while and menu-driven programs. So do while can be used in a menu-driven program to bring the user back to the menu to make another choice. So to simplify the processing of a user input, use the to upper or to lower function. So you have some examples. So you have do and then some code while choice is yes, because so the conditions could be written in this case. This is regardless of what the user enters, whether they enter a capital Y or a small case Y. Then you have the for loop. The for loop is when you actually know the number of times you want to run that program. Like for example, if you guys watch The Simpsons, when Homer is it still running? When Bart Simpson gets in trouble, what do his teachers make him do? 500 times on the wall, on the board, you will not do this again, you will not do this again, right? I will not do this again. So if you know 100 times, 5 times, 10 times, whatever, then you can put that in the for loop. You initialize it. So this is a pretest loop that executes 0 or more times. It's useful for counter control loops. So you initialize it first, you start from 0 or you start from 1, test it. Is it still less than how much you said it will be? Less than 100, less than 10, whatever you said it will be. Update means the increment. Add 1 to it or minus to it, whatever you want to do it. All right, so these semicolons are required here, and then one more statement. And then you just have to write that statement, I will not do this again once, then you don't have to worry about any spelling issues. Then it will keep on executing. And then the loop mechanism. So you have for count equals 1, as long as count is less than 5, then increment for me. Add 1 to it each time. Okay, so you have initialization code, then you test it. If it's false, you exit. If it's true, you will keep going and it will update, keep going. It will update, keep going. Okay, so an example of a for loop. So if test is false, then the first time it's evaluated, the body of the loop will not be executed. So the updated expression can be incremented or decremented by any amount. Variables used in the initialization section should not be modified in the body of the loop. So you can define variables in initialization code. Their scope is the for loop. So initialization and update code can be contained more than one statement. So separate the statement with comma. So you can have int sum equals 0, num equals 0, num less than 10, num increment, and then sum plus equals num. You can omit initialization if already done in the header. You can omit update if done in the loop, and you can omit the test, may cause an infinite loop. Okay. And you can omit the loop body if all work is done in the header. These are optional. You can have running total with the loops. It's accumulated sum of numbers from each repetition of a loop. So accumulated variable that holds running total. So you have initialize sum equal to 0, num equal to 1, and then as long as it's less than or equal to 10, then increment the sum. Okay, so yeah, add sum, whatever the num is, and then increment the num. And see out some of the numbers 1 to 10 is there. You have what's called Sentinels, a value in a list of values that indicates the end of the list. So a special value that cannot be confused with a valid value. So for a test score. Used to determine an input when a user might not know how many values will be entered. Okay, so here you have int total equals to 0, and then enter points earned. Then you have the points. So if the point is not -1, basically something that is out of the norm, right? And you're incrementing it, and then it will give you the values at the end. So deciding which loop to use. So think about the 2 examples that I've given you, or the 3 examples. On the restaurants, you have a pretest loop. While it's a pretest loop, loop body might not be executed at all, because it has to make sure in the case like for drive-through restaurants, they have to make sure they got the money first. And do while is like a dying restaurant. So post loop body will always be executed at least once. Like they have to serve you something first before you actually order the food. The for loop is basically you know how many times something would happen. So loop body might not be executed at all, has initialization, update code. It's useful with counters or if the precise number of repetition is known. You can have a nested loop inside a loop. It's an example of it. So for row equals 1, row less than 3, row plus plus, and then at the end. So this is like if you're doing some type of table, okay, or a matrix. So inner loop goes through all its repetitions. For each repetition of outer loop, inner loop repetition completes sooner than outer loop. So total number of repetition for inner loop is product of a number of repetitions of the two loops. In the previous example, inner loop repeats 9 times. And again, run some of these programs as you see. You can use a break to determine execution of a loop. Use sparingly if at all makes code harder to understand. So when used in an inner loop, terminates that loop only and returns to the outer loop. You can use continue to go to an end of the loop and prepare for the next repetition, while do while loops go to test and repeat the loop if the test is true. For loop goes to update steps, then tests, and repeats loop if the test condition is true. So use it sparingly, like break can make a program logic hard to follow. You can use files for data storage. So we can use a file instead of a monitor screen for program output. Files are stored on a secondary storage media such as a disk, and the files allow data to be retained between programs and execution. We can later use the file instead of a keyboard. One of the assignments that I have for you, you can write it to a file instead of making an output, and with Rectal, you can just create that file on the left side. File types: a text file containing information encoded such as text such as letters, digits, and punctuation. Can be viewed with a text editor such as a notepad. Then you have a binary file contains binary zeros and ones. And information that has not been encoded as text, it cannot be viewed with a text editor. You can have a sequential access or you can have a direct access. These are the two types of accessing file. Sequential access reads the first piece of data and then read the second and so on. And then for random or direct access, it's retrieve any piece of data directly without the need to retrieve preceding data items. You can use built-in functions. Fstream includes definition for ifstream and offstream. Ifstream input stream class. Offstream you can use output stream class. So define files, a file stream object. An object that is associated with a specific file provides a way for the program to work with that file. And then what is needed to use files. So offstream, so some of built-in functions you can use to read files. Opening the file, use the open member function in file.open inventory.data, out file.open report. Again, you can use these similar to one of the assignments as a bonus. File name may include drive, path, info, output file will be created if necessary. Existing output file will be erased first. Input file must exit for open to work. Use the file can use output while object is to send data to a file. And you can use input file to the greater than to copy data from the file. So this is like the syn and the cout. And then you can close the file, use the close member function. Don't wait for operating system to close files and program. And so they may be limited on a number of files. They may be buffered output data waiting to be sent a file that could be lost. So you avoid memory leaks. So you make sure you close the files. So input file, the read position, location of the next piece of data in the input file, initially set to the first byte in the file. And the advantage for each data item that is read successively reads will retrieve successive data items. And you can look at some examples that exist. You use loops to process reading files, so it's not necessary to know how much data is in the file or will be written to a file. So several methods exist to test the end of a file. And so some examples, you can use end of file. Okay, this can be tested to find the end of the file since the read fails when there is no more data. You can have file open errors. Again, you can use the part of input validation. An error will occur if the attempt to open a file for input fails. So file doesn't exist, file name is misspelled, file exists, but it's in a different place. The file stream object is set to true. If the open operation succeeded, it can be tested to see the the if file can be used and how it's done in the loop. You can have a user-specified file names that are different than the normal. So here you have program can prompt the user to enter the names of an input and output files. This makes the program more versatile. File names can be read into a string object. We have a C-string representation of the string object can then be passed to the open function. And then you can create a good test data. So when testing a program, the quality of the test data is more important than the quantity. So this test data should show how different parts of the program execute, and you should evaluate how program handles, whether it's a normal data that's at the limits, that limits the valid range, invalid data. So let's look at some of the examples we have seen and maybe run it to give you how these loops work. So let's use maybe this example, the input validation. Again, some of these you can run it and then test it. So this was a number, enter a number between 1 to 100. Test it, then you read the number. While number is less than 1 or number is greater than 100, see out number must be between. So it keeps on saying this message as long as it's false, right? Re-enter the number. And then maybe if it's right, you can say, something like you have entered a valid number. Then maybe you need to initialize it first and then say maybe int number. Something like that, I guess. All right. So enter a number between 1 and 100. So if I enter 101, it will say what? Because that false is greater than 100, right? So it says number must be between 1 and 100, re-enter the number. So that's the part that's executed. And then it says re-enter the number, so it's waiting for me to enter some other number here, right? How about if I enter -5? It will still say the same thing. Because it's still what? So it still happens between, it's less than 5, so it's the while loop still, the condition is still true, so it will still execute here. All right, how about if I enter 6? Now we'll say you have entered a valid number, so it will exit because it became true, so you have entered a valid number, it will say number. Okay, so this is an example of a while loop. I mean, you can use it depending on whatever program you're planning to write. All right. And again, when you get these examples, just try to run it, test it, modify it, and play with it. All right.